Welcome to my next video on the ocean floor, where I will be discussing my 3D diorama and how I made it, and the characteristics that are shown on it. So first I'll discuss how I made the 3D model of the ocean floor. The first phase was just cardboard and paper sacks from Crest. So I took an Amazon box and then used the paper bags to kind of smooth out the surface and define the ridges and the islands. The second phase was just paint, so you could see a difference between the land, which is green, and the water, which is blue, and then the ocean floor was just left that tan color. And then I added some details just to give it some perspective. So there's some cotton ball for the volcanic island to show that it's active, some cling wrap to show where the surface of the water is, and then some labels so you know which sections of the model I'm discussing. And then this is just a bird's eye view to show you what it looks like from the top. Next, I will be discussing the features of the ocean floor and the three main regions that have each of these features. The three main regions of the ocean floor include the continental margins, the deep ocean basin, and the oceanic ridge. The continental margins consist of the continental shelf, continental slope, and continental rise. The deep ocean basin consists of the trenches and the abyssal plains and the seamounts and volcanic islands. And then the oceanic ridge is simply just that. So zooming in on this side of the 3D model, you see the continental shelf, continental slope, abyssal plain, seamount, and volcanic island. So the continental shelf begins at the shoreline and will gradually slope downwards as it extends to the continental slope. And then the continental slope is going to be very steep and kind of drop, and it's going to extend either to the continental rise or a trench, depending on if it's an active or passive margin, which I'll get into later. The abyssal plain is a very relatively flat surface, which is composed of lots of sediments that have sunk to the ocean floor and happen to make a relatively smooth layer. The seamounts are volcanoes that are still underneath the surface of the ocean, but once they grow tall enough to go past the surface of the ocean, they end up becoming an island above the water. The mid-ocean ridge forms from upwelling from the mantle beneath the oceanic crust and will generate new additional crust. And this will form a mountain range-like texture, and they will have a height similar to the mountains on the land. And trenches are very long and they're relatively narrow, and they extend deep beneath the abyssal plain and consist of some of the deepest parts of the ocean. Next, I'll distinguish how to tell the difference between the active and passive continental margins. So a passive continental margin will have a continental shelf, which extends to the continental slope, and then there'll be a continental rise before you get to the abyssal plain. So you can see this kind of on the left side where there would be a continental rise between the slope and the abyssal plain. Now the active continental margin does not have a continental rise. Instead, it will go from the continental shelf to the continental slope and then to an ocean trench. And that trench is caused by the oceanic crust colliding with the continental crust. And because the oceanic crust is more dense, it will sink beneath the continental crust, causing this really deep trench. And so based on those features, you can see that on the left side we have the passive continental margin, and then on the right we have the active continental margin where that trench is. And this concludes my video.